Today we are going to solve 1- and 2-step problems using data. Our FE is 5.9c. The student is expected to solve 1- and 2-step problems using data from a frequency table, dot plot, bar graph, semi-mixed plot, or scatter plot. So by the end of the unit, you will be able to solve problems by analyzing the data in frequency tables and use them to predict frequency of the same thing occurring when data is multiplied. You'll be able to understand that a dot plot is a graphical display of data using dots. You'll be able to identify the range of a set of data by finding the difference between the greatest and least numbers. Understand that a bar graph is a graphical display of data using bars of different heights and lengths. Understand that a semi-mixed plot is a special table where each data value is put into a loop, usually without the last digit, and stem, the other digits. You'll be able to understand that a scatter plot is a graph of plotted traits that show the relationship between two sets of data. And identify if both x and y values on a scatter plot are increasing, decreasing, or if there is no relationship. So last year, you were able to represent data on a frequency table, dot plot, or semi-mixed plot marked with whole numbers and fractions, solve 1- and 2-step problems using data in whole number, decimal, and fraction form in the frequency table, dot plot, or semi-mixed plot. This year, you will know how to solve 1- and 2-step problems using data from frequency tables, dot plot, bar graph, semi-mixed plot, or scatter plot. And next year, you'll be able to use that information to summarize numerous data with numerical summaries, including the mean and median and the range and interquartile range, the IQR. So the first graph we're going to look at is the bar graph. Give me a thumbs up if you remember seeing bar graphs last year. Good. And in your mind right now, take a minute to think about what all you know just by looking at this bar graph. What information can you find out? If you think you have an idea of the data yet, Jose, what is one thing that you know from this graph? You know that the movement part achievement is what is being shown. Good, you found that from the title. What else do we know actually? So we know the age and the attendance is what's being compared. So you can use this to know that under 2 years old, 175 people are attending. Between the ages of 2 and 5, 200 people. Between the ages of 6 and 12, you have 350 people. Between the ages of 13 and 19, you have 550 people. And 19 and older, there are 475. So do you think you could take this information and find out the total amount of people that are attending? Yes, I agree. So we're going to do one example problem to show you what we found from our bar graph. So in your mind, you're thinking about, is it true or false that more than twice as many 6 to 12-year-olds attend the amusement park as 2 to 5-year-olds? So in your head, you're thinking about whether this is true or false. Turn to your elbow buddy and discuss what you may think. If glasses on, please stand up. If your hair is in a ponytail, sit down. Okay, Edward, do you think this is true or false? Okay, Edward says false. Do you agree? Good, I do agree. Because that's true for more than twice. Is that important? Mm-hmm. Edward, how else do you find out? Do you look got your 6 to 12-year-old and your 2 to 5-year-old. Good. How many people were there that were 2 to 5? 6. And there are 2 years above it. And how many people from 6 to 12? 350. You found that. And we'll keep. And is 350 more than twice of 200? No, good. Not quite as fast. Next, I need you to turn to your dot plot. So on your dot plot, you see that you have a number line. So there's no information there. You just have data listed above it. You have a range from 85 to 97. So how a dot plot works is each dot is going to represent a different number. If you have a key that says each dot represents 2, then you need to apply that to your information. Right now we just have 1 dot per number. So our first number that we have is 86. So above the number 86, we're going to put a dot. We're going to cross out the number 86 because we've got 86. The next one is 88, so you put a dot. Cross it out. And make sure you're plotting your points on your dot plot as well. What is our next number? 90. Good. So what are we going to put above 90? Good job. About 87. Cross it out. 97. Good. So we have a second 91. So you're going to put the dot directly above it. So you're going to have a vertical line of dots representing each number. Right. On your own, you'll let you finish the rest of the dot plot, and then we'll discuss it in about 35 seconds. And we really got to about 85. Okay, how many people have about 85? 3? Yeah. We agree? Josh, how many people have about 87? We agree there's still only one? Okay, let's look back around and see. We already have 187 together. And then there is another 87. Josh, tell me that you know about 87? And as a class, how many about 88? Do we have anything about 89? 90? 91? 92? 93? 94? 95? 96? 97. Right. So in your mind, looking at this information, what do you think this is something? Step 24, what do you know? Right. The lowest test score is 85. You gotta come up with the highest test score. 87. What else do we know? Amber? Good. You know 20 people touch the test. You can count your dots in the previous one and compare to our data. Jeffrey, give me one more thing that you know from the test. So we know the most common form of one, and force you to second one. Turn to your stimulus plot. So from our stimulus plot, the first thing I want to look at is my key. The key is telling me that 1 and 2 on the stem side, the 4 on the leaf side, means $1.24. So look at this. This is representing $1.24. So it's not 124, it's not just 4, it's not just 12, it's $1.24 today. That's not from my sheet. So I'm going to mark that out. We also, we see that we go all the way up to $1 expression. That's our highest number. So we know that we have numbers from $1.30, $1.40, $1.50. Do you have anything else that is $1.20? So what you're going to do is just put 5 here. So this is $1.24, $1.25. These are two different numbers. Do you have anything else that's in the $1.20? No. So now we're going to look at the $1.30. If we have $1.33, we have another $1.33. So you need to put that second 3. That shows that there are two different $1.33. Okay. What else do you see? Okay, we do need to. Do you have anything left in the $1.40 range? In the $1.40 good job. And our last one is just 0 for $1.50. So this 0 is representing $1.50. It's not representing that there was 0 in $1.50. It's saying $1.50. Now to your highest number, and you're going to think about what is my lowest number. It's worth the $1.24. So your range will go from $1.24 all the way up to $1.50. And if you want to know how many different numbers you have, you just count on the big side. So you can put 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 different numbers. Let's turn to your scatter plot. Here we have two different scatter plots. We have A and we have B. From a scatter plot, you can tell the correlation. So here, this would be a positive correlation. If it's going up, if it was going down, it'd be a negative correlation. And here, it's showing that there's no relationship at all. Some of it's going up, but we have an outlier. So that's no relation. But from this information, we want to find out which scatter plot is representing our data. So we have J as our X, and I as our Y. We know that our X is always on top, and our Y is always on bottom. Here your X-axis is horizontal, and Y-axis is vertical. And remember that we always walk before we jump. So when you're plotting your points, you have to go over and then up. So we have 1 and 3. And J1, the height of the plant was 3 meters. So we go over 1, up 6, that is next spot. Okay. And then over 1, up 3. Let's find out which way. So over 3, up 8. Oh, and then they went over 8, up 3. So they did the opposite. Does everyone see that? And then if you finish this, which one would be correct? We all agree that it'd be 8. And the last data that we're going to look at today is our frequency taking. So frequency taking, you're going to have different stovetop crystals listed, and they're putting it in the ice cube, and they're favorite. So this is an ice cream recipe. So first we have our raw raisins. We have thinless, we have shortbread, and we have peanut butter. If they didn't already have this listed for you, you would just go to your data and fill it in. So we're going to use tally marks to represent our frequency. So we have rah-rah raisin, and pasta, and we use to your tally. Sandwich, toss it out, put your tally mark. Shortbread. Tea. And so on. So continue on your own also. From this information, you have a total of students that voted. You can count your conduct, where you see 3, 6, 9, 12, 13, 7, 10, 15. So this is the text on the calendar. You can tell that there were 5 students that like Finland, there were 5 that like peanut butter, and at least 3 that like So now, I would like for you to put your head on your desk and close your eyes. We're going to do a 6 to 5. So this will be if you completely do not understand anything that we did today. You need a 1 or 2 answers. If you kind of understood it, you just don't have a lot of questions. A 3 if you understand about half of them. 4 if you understand the majority of them, or 5 if you completely understand everything that we did. So raise your hand up high, press the 5, and make sure your eyes are closed. And then raise your head. And then I would partner the students up based off of how well they're understanding it. I would try to pair them with the students that aren't understanding it as much as students that are. And we would do matching activities. And then at the end of class, we would do a check it out with on their post-it note, they write down a topic that could be used in the job class. And